Why is the axis important for Python NumPy array creation? Have you ever wondered how data is organized in Python's NumPy arrays? Today, we will discuss the significance of the axis in array creation. Understanding this concept is key to effectively working with data in Python for data analysis. In NumPy, the term axis refers to the dimensions along which operations are performed or how arrays are indexed. When you create a NumPy array, you are defining a structure that can have one or more axes. For instance, a one-dimensional array has a single axis, known as axis 0. A two-dimensional array has two axes, where axis 0 represents rows and axis 1 represents columns. Each axis corresponds to a dimension that organizes your data. The axis plays a vital role in several ways. First, it defines the dimensions and shape of the array. For example, if you create an array with a shape of 5 by 3, it means there are 5 elements along axis 0 and 3 elements along axis 1. This structural detail is essential for ensuring your array has the desired form. Next, let's talk about indexing and slicing. When you want to access or slice elements in an array, the axis helps you interpret the indices correctly. In a two-dimensional array, the first index relates to axis 0, which refers to rows, while the second index relates to axis 1, which refers to columns. This makes it easy to target specific parts of the array. Sometimes, you may need to add a new axis to increase the dimensionality of an array. This is particularly useful when aligning arrays for operations like broadcasting or preparing data for machine learning models. NumPy provides functions like NumPy new axis or NumPy expand dimensions to insert a new axis at a specified position, changing the array's shape accordingly. Aggregation and computation are also influenced by the axis. Many NumPy functions allow you to specify an axis parameter to determine the dimension along which to perform operations like summation, mean, or maximum. For instance, summing along axis 0 aggregates the data column wise, while summing along axis 1 does so row-wise. This flexibility is essential for data analysis and numerical computations. When creating arrays from functions or lists, specifying the shape and understanding the axes helps in structuring your data correctly. For example, creating a two-dimensional array from a list of lists results in an array with two axes, where each axis corresponds to a level of nested lists. Mastering the concept of axes allows you to create arrays that match the logical structure of your data and apply operations accurately. It also aids in reshaping arrays, performing broadcasting, and using advanced indexing techniques, which are fundamental skills in Python programming with NumPy. In summary, the axis is a foundational concept that governs how NumPy arrays are created, accessed, and manipulated. Understanding this concept is essential for effective array handling and data analysis in Python.